Okay, hi everyone, let's get started. Thanks for joining us today. We're excited to have you here. My name is Zainab from the customer support team here at Solargis. And today I'm with Giri, who is the CEO of our Americas office. And in today's presentation, we will be talking about the impact of extreme weather conditions on PV projects. So let's take a look at today's agenda. We will start with a short introduction to our company and give you some exciting news that we have about our model update. And then we will dive right into today's topic of discussion and discuss some extreme weather conditions affecting solar projects. We will specifically look at some examples of these different scenarios and their effects. And then we can also discuss how our services can help you in the design phase to take these extreme cases into consideration. And then to wrap up, we will talk about some upcoming events and have a Q&A session. So if your question is not answered during the Q&A session today, not to worry, we will follow up with an email answering any questions. Also, today's session will be recorded and we will share the recording with you after the webinar. So now let's talk a little about us. Solargis is a leading technology and consultancy company providing energy-related meteorological data, software, and consultancy services. And since 2010, we have been supporting the industry in site qualification, planning, financing, and management of renewable energy projects. And our main mission is to reduce weather-related risks and costs associated with systems planning, performance evaluation, and forecasting. And we are a global company with our HQ in Slovakia and our offices in Canada and Singapore. And today, actually, we're joining you from the Canadian office. Here you can also see some of our services. So prospect and evaluate are helpful in the pre-feasibility, site selection, and design phases. And monitor and forecast are for operational plans. And we also have analysts, which is one of our newest tools for automatic QC check and data analysis for the PV industry. And we currently have more than 1,000 customers in more than 100 countries worldwide using these tools actively. And we have seen more than 1,000 consultancy assignments, and we bring more than 23 years of experience to the field. Okay, so as I mentioned, we have some exciting updates about our model in the GOES region. So that's for Americas. So we made enhancements to our model, which results in a more accurate representation of clear sky days, meaning you get more realistic GHI and DNI values. So on the right here, you can see the GHI difference map, which compares our old GHI versus new GHI. And another update is that we now have a higher temporal resolution starting from 2019. So previously we had 15 minutes. Now we provide data at 10 minutes. And also on the right, you can see that we made significant updates to remove spatial noise and achieve smoother pixel transitions. And this is especially important for mountainous regions and low satellite viewing angles. We also now have more accurate calculations of the sun position, as well as irradiance changes due to solar eclipse events. So we wanted to share this exciting news with you that we have today, but of course, we're always working on improvements and we follow a very scientific approach. So we will keep you posted for any future updates. So I will pass it on to Gideon now to get started.
Hello, everyone. I hope everyone can hear me. Thank you, Zainab, for the introduction. And it's nice to meet all the attendees here. It's been a year since the last webinar from this office. So we are excited to share this information about extreme events. And I know the attendees are from, we understand that the attendees are from different countries, different continents. So good morning, good afternoon, good evening from wherever you're joining from. Happy to have you here. And like Zainab said, the webinar is going to be recorded. So yeah, we're going to talk about extreme weather events today. And we just picked up a few of them. Of course, it's a little bit more extensive than what you see here. Like we have like 5 samples here of the extreme events, but it's actually more. Just getting started, like what's an extreme event? Anything that deviates from the regular or typical conditions or assumptions that we make for a project. So, and the most discussed or the most important ones are here, which is aerosols, wind, hailstorms. You're hearing about this more recently a lot. We talk about thunderstorms, which is a combination of heavy winds, lightning, and also a lot of rainfall, which means there's also going to be flooding. But yeah, maybe we might not be talking too much about the thunderstorms today. But and finally, the temperatures. Temperatures are usually more predictable, but sometimes, yeah, we have surprises. So we're going to talk about some of the extreme lows and highs and how to kind of have some mitigation strategies. Or, you know, how do you take this into account? That's also very important. So, in this presentation, you're going to see about 6 cases. On the, we'll start with aerosols first, followed by some topics on temperatures, and then the usual suspect, the wind, and finally hailstorm. Okay. By the way, we have a poll. I'm handing it over back to Zainab.
Okay, thanks, Giri. So now for our customers who work on the design side, we're curious to hear what your current procedure is like for taking preventative measures for these extreme weather events that Giri showed you. So I will start the poll. The question is, how do you prepare or / account for extreme events in your PV project? So you can select TMY, historical time series, we don't, or other. So let's give it a few seconds for everyone to submit their responses, and then we can take a look at them together. I see a lot of people are still submitting their answers, so I will publish them in just a few seconds. Okay, everyone, thanks for submitting your responses. I'll publish the results now. So you should be able to see now that some people said TMY, some people said we don't or other, and majority of you said historical time series, which is really nice to hear. So now I'll pass it on to Giri to talk more about that and dive right into today's topic.
Thank you, Zainab, for consolidating the information about the poll. It's interesting to see that we still have some of them still using TMYs. So it could be really interesting for people who selected option 1 and also maybe option 3 and 4. For people who selected the time series, I think you're doing great. But still, some parts of the webinar could be interesting for you. And also you can learn more about how you can use your time series. There are different strategies that we want to share today. First thing first, so we're going to talk about aerosols. The first 2 cases are going to be about aerosols. And the first one is the most popular forest fires that we're hearing a lot these days, especially in North America. So we recently had a massive forest fires in Canada this year, which not just in the eastern part, but also around BC as well later this year, which really did cause a lot of aerosol pollution in New York and Toronto, and a lot of PV projects do get affected. And likewise, I think everybody should be aware of the forest fires that happened in California back in 2020 and also last year. So this is happening more frequently, and we are always asked questions on, hey, does your model take into account forest fires, and how does that impact on the radiance? So the first answer is yes, the model does take into account forest fires. And here is a clear example that we wanted to show you how it affects and how we model it. So when we use inputs into the models, so one of the most important component is the clouds. So the images from the satellites which look into the clouds, and the second most important one is the aerosol particles in the air. So we use a separate model for that. It's usually termed as AOD, um, and it's aerosol optical depth. As you can see, for this specific case in California, back in 2020, around September, around the same time, we had forest fires, which created a lot of pollution in the air, a lot of smoke, smog, and it doesn't only stay just in California, it does spread all across the continent, from all the way from the west towards the east. And every time it's going to pass over your PV project, it's going to create a reduction in the DNI. As you can clearly see, on the days when the AOD is quite high, the DNI goes down. That's the second graph that you see. And also it affects the GHI, because the diffuse component is going to be more. GHI is nothing but the global horizontal radiance. It's a combination of the DNI and the diffuse. So especially for large scale systems, if you're using tracker technology, it's very important that your tracking manufacturer has a low light, or let's say diffuse condition tracker algorithms included in your tracker technology. This way you can benefit by just simply looking at the sky directly rather than tracking, and you get more GHI. And it's very important that this is incorporated into your tracker technology. And we're seeing more and more of this incident. And for upcoming new developments, we see that it would be very, very critical to assess the forest fire-based aerosol impacts on your project. So like you see here, it's just not going to only stay in that specific area where there's going to be a forest fire. So it's always important to study the seasonal effects and how often it happens, every 5 years or 10 years. Or more frequently. This is something to keep in mind, and also kind of factor this into your extreme event assessments or your due diligence before construction or even during operations. I think it's going to be very beneficial how we optimize the operations too. I'll move to the next case now. By the way, yeah, so feel free to contact us if you want to study more about forest fire-based impacts. So we now have some risk studies on this, and we'll be happy to provide you some data and also reports based on this. The next one is again about aerosols, but this time we're going to talk about sandstorms. Back in 2020, just last year around March, so there was a sandstorm event that happened in Africa, but it had impact in the southern part of Spain. So aerosols do travel, and also sandstorms, they do travel. If the sand particles are pulled up by the low pressure belts, it's going to move elsewhere from the origin. And here is an image that our colleague Jose Antonio from Malaga, Spain, did share with us. You can see orange skies because of aerosols, because there's so much diffused radiance and very less direct. As you can clearly see on these specific days, the direct radiance was like to nothing. It was very little, and just the GHI was there because there was a lot of diffuse component in the air. So we can model this. Of course, the model takes into account the aerosols caused by sandstorms. So we do model it. So that's good. So we can model that. But what's important is to also notice that especially with sandstorms, it doesn't cause impact only on that specific occasion or that instance or those few days, but these sand particles could also settle down, which means that it could create a layer of soiling on your modules, and this might have a higher soiling loss and could last for a much longer time. So if you don't have proper cleaning strategies in place, or is it something that you didn't expect to happen during that specific season, so it might have a much higher revenue loss on your project. So this is something much more impactful than forest fires, because forest fires, of course, it does create lower radiance, but it moves on. But with sandstorms, it's going to settle down and create a much longer impact. So this might require more study, due diligence, and also some mitigation strategies in place. So we have all the data. If you're using time series, you can clearly look at this part in Spain, which got affected because of the sandstorms, and it's there part of the time series data. I'll move to the next slide. Yeah, we're moving now from aerosol to temperatures. So we have a couple of cases here, case 3 and case 4. The case 3 is going to be about the extreme lows, and case 4 is going to be about extreme highs. and how we can help you study temperatures. So with the time series data, you'd be able to look at the full time series of temperatures for any location in the world, except the North and South Pole. That's where we don't model. But if you use our time series data, you can look at what really happened historically in the last 25 years for customers from Americas region. For European and African region clients, we have data for more than 30 years. Likewise, 25 years again in Asia and further East Asia and Australia, we have data for more than about 15 years. So you can actually make use of this full-time series to study the historical lows. As you can see in this specific case, what happened in Texas back in 2021, the Uri storm, which created massive interruption to people's livelihood, and also it created a lot of trouble for all the power generators, because it's just not only PV plants that got affected, but also wind, other oil and gas, and several other types of generators. But for PV, what's interesting is you may have designed your system looking at long-term historic. Of course, you might have used historical data to do your designs, but if you had used TMYs, so then you might have considered only typical case scenarios, which means that it's not going to look at historical extreme lows. And if by chance, if your plant had to shut down due to interruption in the grid, there might be problems for the there might be a case where your plant might have trouble to kick back in when the grid really wanted you to start back, because there is a high chance that the open circuit voltage of the inverters or coming from the modules could be a lot higher than the rated capacity of the open circuit voltage, total open circuit voltage of the inverters, because the modules are tested as standard testing conditions. For every 1 degree reduction in temperature, there's going to be increased PV production. Of course, it depends on several parameters, the radiance on that specific case. It also depends on what's the age of the module, assuming that it's a new power plant connected quite recently. And if it was constructed using TMYs and your plant had to shut down, there is a high possibility that you might have ended up with a open circuit voltage error because the voltage was above the design conditions, and your plant cannot connect back because the temperatures are very low. And this is very critical when you consider your design, to look at the full historical time series, and make sure that you take into account the historical low temperatures into your design. We know that everybody looks into the historical highs, but also the lows are very important, especially the open circuit voltage issue. And this could be avoided if you use reliable time series data and into your calculations. Of course, the meteorological models do have its own uncertainties, but the best way to approach this would be if you have a weather station at your project site where you're doing your project development activities or your due diligence. It's always good to validate this against the weather models that we offer. And we could even site adapt your temperature data, making sure it's very close to what it's supposed to be. In general, our temperature models are very, very good, very accurate. We have done a lot of validation. Plus, we have also altitude adjusted based on the terrain models. So our models perform very well, and it's very accurate. In this specific case, you see some sample graphs on the right side. By the way, this was constructed using our solar analyst tool that Zainab mentioned in the beginning. So we have this, we use this tool. You can learn more about this later. We can share more insights if you're interested. And there is also a series of webinars about Solargis analysts. So we use this tool to construct these graphs. You can clearly see that in year 2021, the specific site in northern Texas had the most lowest temperature of all the historical series, which is very interesting. And the model did capture this lowest temperature. Yeah, we can offer you this time series data for any location in the world, and you can benefit by having this information and incorporating this into your design. I'll move to the next slide. So now we are just going to talk about the flip side. So we spoke about the low temperatures. Likewise, we have high temperatures as well affecting PV projects. I think everybody's aware of this, especially because for higher temperatures, the modules do have performance degradation. So this way, it's going to create lower power than what's expected. But with the time series, you can be much prepared. Let's say if you have used TMY And if you had done simulations, you may not have considered these surprises. And in this specific case, in June and July of 2023, what we noticed was, this was southern Texas, southern part of Texas. What we noticed was, you can see the highlighted um, um, on the top right graph. You can see the highlight where the temperatures above the historical series temperatures. For of all the historical temperatures, you see it had the highest temperature both in the June and July, and also on the bottom table you can see that we have highlighted the 30.9 and 31.9 is the average of that specific months in 2023. It was the highest of all the historical Junes and Julys, which is an extreme event, and this is going to cause not just performance degradation, but it's also going to cause you revenue loss if you hadn't considered any of these extreme cases into your design or your production estimates. Likewise, there is also a different, of course, it's going to cost you revenue loss, but if you're a customer using PV plus storage, it also gives you a lot of intelligence. The time series data is going to give you a lot of intelligence on when or how many such instances do happen on this specific site, and you could actually benefit by storing and discharging more power if you can in the spot markets, if you can already take these into your design considerations and try to understand the revenue benefit of having such data or having such dispatch strategies on your project. So the time series data is not only going to help you with the design and due diligence, but you can also use it to understand how many such extreme events do happen for a particular site, and how do you prepare yourself on different dispatch strategies. This way you can also have gains in revenues, because usually when there are constraints during such high temperatures, because everybody's going to turn on their HVAC system to cool the houses or the the commercial units. So this way the dollar value is going to go up during these instances, and you can actually benefit by discharging during this time and gain more revenues. So the time series data is going to be very helpful for you, and it's very important to also use this into your modeling strategies, not just on the design, but also into the revenue models. So this is something we wanted to share today. Moving on to the next slide. Yeah, so here we have moved from temperature to wind. Wind is more common; it's everywhere, but it's intermittent. It's more complicated. Likewise, wind is also there during the night. So it's very important to take wind. When we say wind speed, wind direction, and wind gust into your design strategies or design modeling, and also with your technology selections. It's very important to keep in mind wind parameters. It's usually overlooked because everybody looks at temperature radiance quite seriously on the PV industry, but wind is usually overlooked. Wind is a very important component as well, and we strongly believe that it should be given more importance. So with Solargis, we do have our own model that meteorological model where we can offer wind speed, wind direction, and wind gust data for any given location. And where we see it could be very useful is, especially on utility scale projects, we see that a lot of the development activity that's happening these days are usually tracker projects. So all the tracker technology companies, they work with this wind data to make sure that the tracker modules, or sorry, the tracker structures could withstand the impacts of the wind on that given specific site. So it's always good to do a proper due diligence on the wind, and also make sure that your tracker manufacturer has done their own wind tunnel testing. Because very recently we're seeing a lot of impacts on the tracker modules, just not causing damages because of very high wind. Even at medium wind, there could be possibilities that your tracker might or your structures might go into a torsional divergence or torsional fluttering issues, which is nothing but, as you can see on this video, we've shared this video here, where you see on the left, you see the modules starting to flutter even at medium wind speeds because it doesn't have a blocking or a braking system in place. Whereas the one on the right, it doesn't it doesn't flutter because it has the protective mechanism. And once it picks up, and if the wind keeps continuing, it can flutter and get into maximum damage, as you can see on the top image. So how we can help? We can offer you this wind data in a time series format, both wind speed, wind direction, and also wind gust. Wind gust happens for a very short time, but it has much higher impact as well. So it's also good to study that. And what could be another interesting thing, especially with studying torsional fluttering or asking your manufacturers if they have taken this into account. The majority of the problem arising because of larger PV modules. The modules are getting bigger and bigger, and everybody's moving from 1P to 2P mounting methodologies, right? So that's also another factor which is causing this. So it's always good to ask your manufacturer if they have taken into account the torsional fluttering, and have they done any wind tunnel testing, proper wind tunnel testing before you approve the manufacturer into the project. And when it comes to your specific site, it's also good to look at the wind rows, which is nothing but you look at a collective data of wind, just not as wind speed, but also look at from which direction the wind usually comes from for that given specific site. At the bottom left, you see two wind rows diagrams. The one on the left is actually from a ground measurement station. And the one on the right is the model, the meteorological wind model from Solargis. You can see that the data is very similar. And also one thing to note here is that the wind rows clearly shows that there is a dominant south and southeast wind pattern for this specific project. So which means that there is going to be more wind coming in this direction. And also it's important to note what's the frequency of different wind speed ranges. And based on this, you can already protect your project. You learn where the wind is coming from and how it's going to enter into your project field. And then you can also try to come up with better protective mechanisms on how you can protect your arrays or your project site based on the direction in which the wind is going to enter. And different tracker companies, they have different strategies like stowing to avoid wind damages, and they might even kind of protect the outer layers of the array in a different way by maybe having a higher angle of attack so that it doesn't get into fluttering. So there are several different strategies. So talk to your tracker manufacturers, and we have all the data to help you. Plus, if you have ground measured data, we can also help you by validating that with the meteorological model, because even if you have a measurement for a year, we can use this information to validate and also site adapt the wind data and the wind gust data for the full time series, and also come up with an updated TMY. That's something we offer as a service. Feel free to contact us on that. So this way you can also study the wind in a longer range, and also try to study extreme wind events, plus at the same time seasonal impacts as well. So during which season do you have higher wind, and how do you protect yourself? This is very interesting, and we're putting in a lot of effort. The meteorological team is really working hard on these topics recently, and feel free to contact us if you want to learn more about this. Moving to the next slide. I think we are at the last case. Here we talk about hail. Hail is something very region specific, and we're hearing this a lot in the US, and also we are hearing more frequently also from Europe. So recently there was an event in Italy as well. So what are hail? Hail is nothing but the water droplets in the air. It usually happens along with the thunderstorms, and when the thunderstorms move the clouds into colder areas, the rain droplets freeze into ice, and then they fall down from the air. And it is usually accompanied by thunderstorm, and the frozen rain droplets for sure, they're going to vary in size. It can be size of a small pellet to a size of a baseball. And the impacts could be a lot different. Small pellets mostly won't cause big damages on your PV modules, but the larger ones, they do. And at Solargis, we are now in the process of collecting more and more data related to hail, because it's more frequently asked. Here, on the top right, you see a map that was a risk map of hail that was generated by Solargis using the NOAA's data from the Storm Prediction Center for hail. And you can clearly see that the central US, or it's also popularly called as the Hail Alley, in the central part of the US, around Texas, Nebraska, around this region where we see higher chances of hail happening, and the impacts could be quite large. And what's something worrying is that there are more projects being developed in Texas ever than before, and it's still going to increase. So how do you protect your assets? It's important that you study the risk in the first place, and also making sure that you select the right technology for your projects. So how can you protect yourself from hail? There are a lot of studies which talk about hail causing damages, and these damages could also vary based on the module technology, the module thickness, and everybody now, most of the developments are bifacial, so it's going to be glass. So which might even have more impact. So how do you factor these into account? So sometimes it might be also beneficial selecting a different technology if you have hail in the specific area. So this is very important. The first thing is to study the risk of hail on a given project location, and then also make sure that you select the right technology if your site is going to be a hail risk location after the study. So it's always good to make sure that you select the right technology for your modules, the right thickness, and how and also selecting the right tracking technology, because you can still protect your asset if you have the right technology and right mitigation strategies in place. Especially the tracker manufacturers, they give you a lot of options on how you can protect yourself from hail, and different tracking companies have their own methodologies and mitigation strategies. So it's important to study them in detail, so you pick the right technology so you can store your modules when there is chances of thunderstorm and hail to possibly be followed. So, and it's also okay to stow more, facing making sure that you don't face the sky directly, but at a higher angle of attack. So this way the impact is going to be a lot less on your modules. Of course, there might be a reduction in PV production by stowing, but we strongly believe that it's better to stow more often than taking the risk, because the damages could be significant, and sometimes it's okay to take a loss on generation and try to protect your asset. So yeah, and we wanted to share a recent example that happened in Nebraska for this 5-megawatt plant just earlier this June 2023, like baseball size hails, at a very high projectile speed of like almost 150 miles per hour, just damaged the entire power plant. So even with some of the best stowing methodology, the chances are pretty less. So it's always good to study the risk and also make sure that you come up with the right technology for your project. And we're working really hard to provide you all this information that you need. And right now we have some data for the US. We'll be happy to share these maps very soon. Feel free to contact us. Likewise, we're coming up with a more global database, and we'll be happy to support anybody who's trying to study the risk of hail. Moving to the next slide. Yeah, we've almost come to the end. So I think I already spoke about how we can help you. So, but still wanted to recap overall. What are the different data and services that we offer today? I think most of the attendees should already know that we offer time series data for more than 25 years of historical data. So you can already benefit using this information into your PV design, and also studying internal variability if you're trying to study different probability scenarios on how weather could impact your PV generation for the next 20-25 years. If you have any difficulties understanding this, we are always here to help. If you have subscription to our Evaluate Pro, we can help you how to get all this information related to the model uncertainty or the internal variability. Our PDFs report that is usually accompanied along with the data already has a lot of insights, but we'd be happy to help you on that. For people who still don't use the time series, still using TMYs, I think it's the right time to also look into this option because there are a lot of benefits, and we still feel that it's worth looking at the full time series for your project due diligence. For assets which are already operational, we have ongoing data, live radiance, and also recent forecast, which comes from our cloud motion vector modeling, CMF, the cloud motion vector model that we offer, which is for the next few hours. So this way you can, if you're working on projects which might have some kind of a thunderstorm risk or any extreme weather event risk, you can already benefit having the recent nowcast that's coming out from our cloud motion vector models. We deliver both via FTP API. API is the most popular. Feel free to contact us. And also we offer other parameters like precipitation and snow that could also benefit. And the third product, which we see, which could be a good add-on to the second one, is the portfolio performance reporting maps and reports that we offer along with the data, as you can see on the right side. So these are nothing but maps and reports that we deliver along with the actual ongoing live data product. So this is usually delivered at end of the month, which consolidates the radiance for a particular region or a country. As you can see, the GHI for let's say June 2023 in the US, and it compares June 2023 against all the Junes, historical Junes. And it's a good consolidated information because for stakeholders, it's very easy to look at where the weather impacts. So how much, so let's say if you have underproduction than a typical TMY case, you can quickly look into if the impact was because of the weather on that specific month. So you can already make sure that if the plant underperformance was because of weather or was it something else. So we can offer you this weather adjusted expectations, as you can clearly see on the table below, which shows the long-term average GHI for a given location and the sum of that specific month, and then you see the delta, which is the difference between the long-term average and that specific month, let's say June 2023. And then you see the difference in percentage. So which clearly gives you the stakeholders a quick idea on if the weather was a factor for the underperformance. And if weather was still not the reason for underperformance, then it's something else. Something's wrong with the project site. So then it's more useful to investigate it further. So we have this service, which a lot of you could already benefit, or clients who are already using Monitor could already benefit having this service as an add-on. We have a lot of our customers, especially owners of large portfolio of assets, they already benefit using this. Feel free to contact us or contact your sales team to get more information about this. Our sales team to get more information about this. And finally, we have something new, which is we have launching a new product called as risk-related service and reports, where we would be able to do a deep dive to study any of the issues that we just spoke about forest fires, about hail, about snow, or wind speed or wind gust. We'll be able to do that, not just based on meteorological data, meteorological models, but also if you have ground measure data, we can correlate that and provide site adapted results as well. So that's something that we are launching, part of our risk studies. So today is the day we are talking about this, and feel free to contact our sales team for more information on this. I think that's it from my side. I am just handing it over back to Zainab. Thank you.
Yeah, so thanks everyone for joining us today. We hope that you enjoyed today's webinar. So if you want to reach us, feel free to email us at contact@solargis.com.